Okay, good morning. In continuation of our report, Introduction of Cloud Physics. Okay, let's talk about growth of cloud droplets. Ordinary cloud droplets are extremely small. The average size is 20 microns or 0.002 centimeter. If the cloud droplet is in equilibrium with its surroundings, the size of the droplet does not change because the water molecules condensing into one droplet will be exactly balanced by those evaporating. If it is not in equilibrium, the droplet size will either increase or decrease depending on whether condensation or evaporation predominates. The mechanism of growth of cloud droplet. First is condensation, followed by collision and coalescence, and also lastly Barber process. Condensation. At a given temperature, air can hold a certain amount of water vapor and no more. When the air holds the maximum amount of water vapor which it can hold at the temperature, the air is said to be saturated. Temperature at which saturation occurs is called the dew point. When air is cooled below the dew point temperature, condensation takes place. Conversion of water vapor into liquid water is called condensation. Next is the coalescence. Coalescence is the process by which two or more droplets or particles merge during contact to form a single droplet or cold bubble. Its role is crucial in the formation of rain. As droplets are carried by the updrafts or downdrafts in a cloud, they collide and coalesce to form larger droplets. When the droplets become too large to be sustained on the air current, they begin to fall as rain. Adding to this process, the cloud may be seeded with ice from higher altitudes, either by the cloud tops reaching -40 degrees Celsius or cloud being seeded by ice from cirrus clouds. Collision coalescence. Air swept is smaller than area of small raindrop. Big water drops fall faster than small drops. As big drops fall, they collide with smaller drops. Some of the smaller drops stick to the big drops. Drops can grow by this process in warm clouds with no ice. Occurs in warm tropical clouds. Collection efficiency 10 and -50%. Theory explaining how the behavior of individual droplet leads to the formation of clouds is called collision coalescence process. Droplets suspended in the air will interact with each other, either by colliding and bouncing off each other, or by coalescing or combining to form a larger droplet. Eventually, the droplets become large enough that they fall to the earth as precipitation. Collision coalescence process does not make up a significant part of cloud formation for the same reason that water droplets have a relatively high surface tension, which prevents them from coalescing on a large scale before they eventually fall to the earth. Next is the Barber process. Primary mechanism for the formation of ice clouds was discovered by T. Barber. Barber process notes that the saturation vapor pressure of water, or how much water vapor a given volume can hold, depends on what the vapor is interacting with. Specifically, the saturation vapor pressure of air with respect to ice is lower than the saturation vapor pressure with respect to air. Interacting with the water droplet may be saturated at 100% when interacting with a water droplet, but the same air would be supersaturated when interacting with an ice. Air will attempt to return to equilibrium, so the extra water vapor will condense into ice on the surface of the particle. These ice particles end up as the nuclei of larger ice crystals. This process happens at temperatures around -40 degrees Celsius. Surface tension of the water allows the droplet to stay liquid well below its normal freezing point. When this happens, it is now supercooled liquid water. Bergeron process relies on supercooled liquid water interacting with ice nuclei to form larger particles. A process hereby scientists seed a cloud with artificial ice nuclei to encourage precipitation is known as cloud seeding. And that would be all, guys. Thank you so much, and God bless.